Let us now see how to set up the cavitation model. We have to go to Phases panel, then go to Phase Interaction, then go to the Mass tab within the Phase Interaction panel, and then select the single-étale cavitation model. But this single-étale model will not appear unless and until we do some text command setting. We will see how to do this. First, just to review this procedure, we go to Phases within Problem Setup, then we click on Interaction. In order to enable the single-étale cavitation model, we have to type solver, set, and export. After typing these commands, a question will come up which will ask whether the single-étale cavitation model should be used. We say yes to this question. Then, when we click on this interaction, within the Phase Interaction panel, a new tick option will appear which is called a single-étale model. We select this model, then these options will appear in order to set the parameters or input the parameters for this particular single-étale cavitation model. We set the vaporization pressure, we set the surface tension coefficient, and we set the non-condensable gas mass fraction. These settings are the user inputs and should be known by the user. The three parameters are vaporization pressure, which is basically the vaporization pressure of the liquid under consideration, surface tension coefficient of the liquid under consideration, and the non-condensable gas mass fraction is basically the mass fraction of the impurities of gases present in the liquid. The default value for pressure is taken as 3540 pascals, which is the vaporization pressure for water at ambient temperature. Depending upon which liquid we are modeling, we can change all these parameters and input them as user inputs for setting up the single-étale cavitation model. Now, we will see how to set up the rest of the cavitation model. In order to activate any of the other two cavitation models, we go to Phases, then click on Phase Interaction. That is, within the problem setup, we click on Phases and click on the Phase Interaction button. Then this Phase Interaction panel will pop up. Here, we go to the Mass tab, that is this particular tab. We select the phases, the two phases that are present. Then in the mechanism, we select cavitation. Please note that we have not activated the single-étale model by using the text command. So in this Mass tab, the single-étale model option is not appearing here. So we select cavitation after that, and when we click on edit, this cavitation model panel pops up. We can select either of the Schnell-Saur model or the Schwarz-Gerber-Bellambry model. We give the user inputs that are required and set up either of these two models that we want to use. So this was all about setting up the cavitation models, either of the three cavitation models that are present. After this, we will just have a short review of the options available, points that we have to take into consideration in order to use mixture model for modeling compressible flows. Whenever we are using mixture model for modeling compressible flows, only one of the phase can be taken as compressible ideal gas. If we specify total pressure at the boundary, that is either a pressure inlet or intake fan, the specified value of temperature at that boundary will be used as total temperature for the compressible phase, but it will be used as static temperature for other phases, that is for the other incompressible phases, because only one phase can be given as compressible ideal gas, rest of the phases are incompressible. For each mass flow inlet, we need to specify mass flow or mass flux for each individual phases. So these are some of considerations for modeling compressible flows using the mixture model. Here we arrive at the end of this lecture. We have discussed the mixture model and important aspects of the mixture model in detail in this particular lecture. As this is an exclusive or a specific model used only in certain cases, we have restricted our discussion only to the important points of the mixture model. If we need to go into detail of rest of aspects of the mixture model, we can either refer the user's guide of Fluent software or the theory guide of the Fluent software. To summarize this lecture, we studied basics of the mixture model. We studied applicability of mixture model. We also studied mixture model setup, and we discussed in detail all the phase interaction options. We studied assumptions and limitations of the mixture model, and we studied the cavitation model in detail. So this is all about the mixture model in Fluent. With this, we come to end of this lecture. The references that we used were basically the Fluent software user's guide and the Fluent software theory guide. So thank you for viewing this particular lecture. See you in the next lecture in this advanced multi-phase lecture series.